This is Professor Mikey. Welcome to 1.2 laptop displays from the CompTIA A+ 220 1101 exam or Core 1 exam. Many of the laptops we use today have an LCD display. This is a liquid crystal display where there are a series of liquid crystals associated with color filters, and there is a backlight or light source behind all of that shine through to give us the image that's on our screen. From a laptop perspective, the advantage of an LCD display is that they are lightweight and they use very little power, but they're relatively inexpensive to make, keeping the cost of the laptops down. There are different technologies of liquid crystal display that you need to be aware of. One is the TN LCD. This is a twisted pneumatic LCD, which gives us very good response times. If you're a gamer or if you're using some application that has fast-moving graphics, this may be the display type for you. Unfortunately, these displays often have very bad viewing angles, which means once you get off to the side of the display, you notice there's an inversion of the color. If you want the best possible view of a TN LCD, you need to be looking directly at the display. If you're looking for the best possible color representation on an LCD display, you want to use an IPS LCD. The IPS stands for in-plane switching. This gives you very good color representation, which is great for using graphics or doing some type of desktop publishing. But these are slightly more expensive than a TN, so that extra color representation comes at a bit of a cost. If you're like something that's in the middle between TN and IPS, you might want a vertical alignment LCD or a VA display. This has good color representation, but you'll find that the response times are a bit slower than a twisted pneumatic LCD. If you have a newer device, you may be using an OLED or an OLED. The OLED stands for Organic Light Emitting Diode, and it doesn't have a backlight. Instead, this organic material emits light when you provide it with a current. Because there's no backlight and there's no liquid crystal displays, these are very thin displays, and there's no glass that you would need on the front of the display to protect it. One aspect of our laptop displays that we don't often think about is how they're used on wireless networks. When you open the laptop, your display is the highest component in the system. So it's a perfect place to run your wireless antennas. If you're using 802.11, Bluetooth, or some other type of wireless networking, then you probably have an antenna that runs to the top of your laptop display. This creates some challenges when you're replacing the display, because you not only have to remember to connect all of the video components, you have to remember to connect all of these antenna wires as well. Many laptops these days have webcams integrated into the laptop itself. That's the small little hole at the top of the camera and a tiny little one next to it, the microphone. This can be obviously used for video capture, but it's also used for meetings and video conference calls. This makes it easy when you need to be on a Zoom call. You can simply open your laptop display and jump on the call. But unfortunately, quality may be a problem. If If you're working with an older laptop or you need to replace the display on an older laptop, you may find that the backlight that it's using is a CCFL backlight or a fluorescent cold cathode fluorescent lamp. Newer LCD displays might use LED lights instead of using a fluorescent lamp. These LED lights may be around the edge of this display, or they might be in a matrix, such as the one that's seen here. These have become so common that instead of people referring to this as an LCD, they often refer to it as an LED display. What they really mean, of course, is an LED backlit LCD, because LCD needs light in the back in order to emit a picture. If you were to pull the front off a display that has LED backlights, you might see that the matrix behind it looking like this. These are strips of LED lights, and you can see each one of these LED lights is a very large matrix behind the display. The display is smart enough to recognize what parts of the display should be lighter or darker and will adjust the lighting depends on what you're viewing. If you're working on one of these older laptops with CCFL or these fluorescent backlights, you may also find some additional components behind the screen. These are inverters. We use these inverters because the CCFL backlight requires AC power, but your laptop is using DC power. The inverters are responsible for taking that DC power, converting it to AC so that we can power those fluorescent backlights. If you're using a hybrid device like this one that has a touch screen and a tablet style, you may be using a high resolution input with a stylus. The stylus allows you to directly draw on the screen. And whatever you're pushing on the screen is converted into a digital signal in the display. We're able to provide that conversion because inside of the display is a digitizer that converts that analog input onto the display into a digital signal that the computer can recognize. The digitizer in your device may only allow for stylus input or one from a touchscreen. A touchscreen digitizer takes input from our finger and converts it to a digital form. It's a very common way to get information into a laptop or a tablet. And we often can use a keyboard or stylus or just press a key and have the same function. Okay, so that is it for Objective 1.2 laptop displays. Let's take a pop quiz. So the question is, what other type of wire antenna would you see in the border of a laptop display other than video? A, USB, B, PCI Express, C, 802.11, or D, AC port? And the answer is 802.11. If you remember that picture, we had all those wires. Yes, 802.11 or the wireless adapter is very commonly wired up to the top of a display. Thanks for watching.